Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's explore Helm. So you will learn what is Helm, why Helm, what are the different components of Helm, how to install third-party applications or Kubernetes controllers using Helm. Finally, you will also learn how to shape applications of your organization as Helm chats. Overall, this is going to be quite informative session. Just make sure you watch this video till the end. Also, to make it simple, I have prepared this GitHub repository. After watching this video, you can go through this GitHub repository for a quick revision. Now, all these MD files has everything that I'm going to cover as part of this video. You can find link to this GitHub repository in the description. Perfect. Let's get started. First things first, what exactly is Helm? In basic words, Helm is considered as a package manager for Kubernetes. Many of you might be familiar with Linux. So let's understand from the Linux point of view. Just like how you have apt, which is a package manager for Ubuntu, Helm in the same way is a package manager for Kubernetes. What does that mean? Today, if I ask you to install any popular package on Ubuntu operating system, let's say if I ask you to install Python 3, you will not go to internet, look for the steps to install Python 3. Like probably you will not write down the steps somewhere, prepare a script. Instead, you will first run apt update to update the apt repositories. Then you will run apt install Python 3. If I ask you to install, let's say OpenJDK, you will just replace Python 3 with OpenJDK. Or if I ask you to install npm, you will just use apt install name of any package that you want to install. In the same way, if you want to install any controllers on Kubernetes, on day-to-day basis, we use a lot of controllers, things like Prometheus, Grafana, Argo CD, Nginx Ingress controller. Now, what are all these? These are controllers in the world of Kubernetes. Or you want to install any applications such as Nginx, let's say, or BusyBox. In either of the cases, you don't have to go to the documentation. You don't have to list out the YAML files, all the Kubernetes resources that are required to install these applications. Instead, you can just use the Helm command. First step, you need to add repository that holds the applications. In the world of Helm, we call it as charts. I'll explain repositories and charts in a while. But for now, just understand, as step one, you will add the repository. And as step two, you will just run the Helm install command. So using Helm install, you can install Prometheus, you can install Grafana, Argo CD, or third-party applications like Nginx. Whatever you use as common things on your Kubernetes cluster. Mostly you can install them using Helm. Perfect. So what is Helm? Helm is a package manager for Kubernetes, which allows you to install Kubernetes controllers or third-party applications. So Helm only allows you to install? No. You know, just like how apt for Ubuntu can allow you to install the package, apt allows you to update a specific version of the package. Maybe first you installed Python 3.10. After a while, you want to update the version of package. Using apt update, you can update that to 3.12, you can update that to 3.13. Similarly, you can also uninstall or remove a package from your Linux operating system. Helm is also capable of all of these things. So using Helm, you can install a Kubernetes controller or third party application. Using Helm, you can update their version. Maybe you have initially installed Argo CD 2.12. You can update that to Argo CD 2.13 using Helm. Similarly, you can also uninstall. And finally, what Helm supports, you can also bundle or you can package the application of your organization as Helm charts so that any people outside your organization or someone outside of your team in your organization can use the Helm command to install your application. Just like how you install Prometheus, someone else in your organization or someone outside your organization can also install your application using Helm. We have a complete demonstration for this particular thing. So I'll take a sample application and demonstrate you how to create a chart, how to use the Helm. But for now, I hope you understood this simple point. What is Helm? Now the big question is why? Abhishek, I understood what is Helm, but do I really need to use it? Like, you know, if I want to install Argo CD, I can just run kubectl apply. Or if I want to install Nginx, I can just use kubectl create deployment, right? Overall, I can install anything using kubectl apply or kubectl create. Yes, in the same way, you can install anything on Linux using curl, wget, or shell scripts. You can install anything on Kubernetes using kubectl. But no, the major challenge comes. Let's understand from Linux point of view itself. Imagine you're working as a DevOps engineer and on every Linux machine of your organization, you have to install 10 packages. Nginx, Apache, let's say Java, Node.js, Python. Now, in this way, you need to install 10 packages because your developers or test engineers, they use these packages on the Linux server. Now, if you don't have apt as a package manager, step one, you will prepare script for installing Nginx. You know, maybe you'll be using a curl command to download the Nginx package. Then you will add the Nginx package to path. Before that, you might have to unzip the package. Then you have to do the configuration required for Nginx. So you'll prepare a shell script for Nginx. Similarly, you will prepare a shell script for Java. Downloading OpenJDK, unzipping OpenJDK, adding OpenJDK to the path, providing the permissions. You will write a script for it. Similarly, you will write a script for Python. You will write script for Java. You might say, okay, Abhishek, I'll write 10 different scripts. That's not a problem. Now, you don't only have to write these scripts. You also have to make sure you have upgrade versions of this script. Different teams might be using different versions of Java. So within your shell script, either you have to make it customizable or for each version of Java, you have a different Java shell script. And you have to make sure they are always up to date, right? The scripts must be always up to date. Maybe the script is written 2 years back and installation mechanism of Java has changed completely, right? The script will no longer work. So every 2 months, every 3 months, you have to go through these scripts. You have to test the scripts to ensure they are working fine. Now this becomes a huge maintenance overhead for the DevOps engineers. And practically this is not possible because the example that I've taken is only 10 packages. Maybe you need to install 100 packages. And these packages also have some dependencies, let's say. So overall, you will be dealing with 100 or thousands of packages on your Linux server. All of this can be avoided just by using something called apt. Just run apt install nginx. It will take care of all the dependencies, whatever Nginx needs, or just say apt install Python 3. It will install Python 3 with all the dependencies. It will add Python 3 to your path. It will provide the permissions. You have everything that is required. Similarly, if you want to upgrade a version, you can do that with apt. So it is reducing huge overhead for your DevOps engineering team. Same is with Helm, right? Always compare Helm with package managers of Linux, because the concept of Helm itself is heavily inspired from the concept of package managers of Linux. So using Helm, you don't have to create multiple YAML files, or you don't have to create multiple scripts for installing Prometheus, installing Argo CD, installing Grafana, because in Kubernetes, installing and configuring can be quite tricky. For Prometheus, you might need to create a namespace called monitoring. For Prometheus installation, you might want to create a service account for it, config map for it. Then you install Prometheus stateful set or deployment. Similarly, installing Argo CD is not only installing Argo CD, it might have config map, service account, and all of them have to be created in order. So if you create script for each of them, it becomes quite complex. Just like Linux, on your Kubernetes cluster, you might be dealing with some 20-30 controllers and some 20-30 third-party applications. All of these can be eliminated using Helm. So just use Helm. You can install the package, you can upgrade the package, you can uninstall, and you can do everything for the management of the package. I hope what is Helm and why Helm is quite clear now. Just to repeat in less than 1 minute, Helm is a package manager for Kubernetes, using which you can install Kubernetes controllers, or you can install third-party applications. You can uninstall them, update them, or you can also create your own Helm charts for the applications of your organization. If you ask why Helm, if you don't have Helm, DevOps engineering team or SRE engineering team might have to create scripts for installing each Kubernetes controller, and also for multiple versions of your Kubernetes controller. Team A can use Argo CD 2.12. Team B might want to use Argo CD 2.13. And you might need a specific replicas of Argo CD for your UAT environment, specific replicas for your prod environment, right? So you cannot keep creating multiple YAML files, or you cannot keep creating multiple scripts. Helm comes as a rescue. Perfect. Now, before we deep dive into practicals of Helm, let's try to understand first how to install Helm. This is important, right? You first need to have Helm on your local machine. Only then you can do everything practically. It's very simple. Just search for installing Helm. Take your browser, search for install Helm, get to the official Helm documentation, and look for installing Helm. Depending upon your operating system, if you're on macOS, just run brew install Helm. If you're on Windows and if you have Chocolate, you can just run this command. Or if you're on Ubuntu, a different version of your Linux operating system, you have apt DNF package managers that can install Helm, right? So just go through this page and install Helm on your machine. But Abhishek, do I need to install anything on the Kubernetes cluster? No. For Helm, you don't have to install anything on your K8s clusters. Before, during version 2 of Helm, yes, that was a requirement where you might have to install Tiller. But from version 3 of Helm, you don't need to install anything on your Kubernetes cluster. Now, this is a great advantage, right? So from your laptop, if you are interacting with 10 Kubernetes clusters, if you had to install a package on the Kubernetes cluster or a controller on the Kubernetes cluster, every time you have to install as you keep adding Kubernetes clusters. Then Abhishek, how Helm can interact with my Kubernetes cluster, right? I have 3 Kubernetes clusters. How does Helm know, that is Helm on my machine know, should it talk to this Kubernetes cluster or should it deploy the packages on these Kubernetes cluster or this one? Very simple. Just like how kubectl works, right? You might have multiple Kubernetes clusters. What kubectl does? Kubectl looks for the current context on the kube config file, right? You have a kube config file. Within the kube config file, it will look for current context, and whichever is the current context. If this Kubernetes cluster is the current context, kubectl connects to that. If this is a current context, kubectl connects to that. Same is with Helm as well, right? For example, now on my machine, if I do kubectl config list, or if I just do, I'm using kind, so if I just do kind get clusters, so you can see that I have 3 different Kubernetes clusters. What Helm does, first I'll show you that Helm is installed. If I just run Helm version, I can see this output. That means Helm is installed on my machine. Now, what Helm does, kubectl config current context. So whichever is the current context, Helm is connected to that particular cluster. So if I'm running Helm install command now, it connects to this particular cluster. Okay, Abhishek, now this is clear. Let's go ahead and install Nginx in the default namespace. How to do that? So you just need to run 2 commands. As I told you, first command is to add the repository. Second command is to install Nginx from that repository. But Abhishek, what exactly is this repository? And what I'm doing with this particular command? You haven't explained the concept of repository in Helm. Don't worry, you already know this concept. Whenever you are working with Linux, what happens when you do apt install nginx? What apt does? Like, how is apt installing nginx? It's very simple. Apt connects to repositories. So by default, there is a repository that is archive.ubuntu.com. Now, all the packages, whether it is Nginx, whether it is HTTPD, or whether it is Java, Python, they are part of these repositories. If the package does not exist in this repository, then there is no way you can install Nginx. By default, the repositories like archive.ubuntu.com, they come up with commonly used packages. That's why when you run apt install nginx, this repository helps you install nginx. In the same way, you need to have a Helm repository which has all the charts. What is chart? Chart is basically a bundle or a package of your application. So if I'm talking about Prometheus, so the bundle of Prometheus is called as Prometheus chart. If I'm talking about Grafana, the bundle of Grafana is called as Grafana chart. So within the Helm repository, whichever charts you have, you can only install those charts. Abhishek, just like archive.ubuntu.com, is there any common repository where multiple charts are hosted? Yes. So this is the popular repository, which is called Bitnami. So Bitnami repository has most of the popular charts that you use on the day-to-day basis. So on your Kubernetes cluster, you can just use this Bitnami repository. I'll show you as an example. If I just add this Bitnami repository, okay, I already have it added, but let me do it again. So if I just do Helm repo add Bitnami, right? It has all the popular charts. To check, you can just run Helm, Helm search. If you just run Helm search repo Bitnami, you will see it has thousands of charts. Who is this Bitnami? Bitnami is one of the popular or one of the common maintainers of Helm. So they are actively contributing to Helm, and they are the popular maintainers of Helm. So they have most of the charts. For example, they have Redis, they have Spark, they have Thanos, Tomcat, Valky, Vault. Whatever you are looking for, mostly they already have it. We can also search for a specific one. We wanted to install Nginx, right? So Helm search repo Bitnami grep Nginx. Great. It already has Nginx, right? Again, I'll just repeat things here so that people are not confused. You all are not confused. So there are two important things. One is Helm repository. Second is Helm chart. What is a chart? Chart is a bundle of the application, or it's the package of the application. So for Prometheus, the developers of Prometheus or Bitnami, what they do, they take all the YAML manifests of Prometheus and they bundle it as a Helm chart. Whatever, if you don't have Helm chart, whatever are the YAML files, whatever are the steps, they bundle all that together and that is called as a chart. So for Prometheus, there is a Helm chart. For Argo CD, there is a Helm chart. For Nginx, there is a Helm chart. All of these charts are put onto the repositories, right? So repository is a centralized location that holds your charts. And the example that we are using is a Bitnami repository, which has thousands of charts. In the same way, for your organization, you can also create a repository and you can create charts for each of your microservice. If you're working in e-commerce application, you can create a chart for payments, you can create a chart for transactions, you can create a chart for shipment, and all of this you can update to a common repository. We will also do this, right? In this demonstration, we will also do this, but it is too early for this at this point of this video. Okay, so let's see how to install Nginx now. We learned what is repo, we learned what is chart. So to install Nginx chart, Helm install, just provide what should be the release name of this chart. So I'll just call it as Nginx itself, or I'll just say Nginx v1, right? Followed by Bitnami slash Nginx, or I can simply copy it from here actually. But anyways, okay. Now let's see in the default namespace if Nginx gets deployed. Clear the screen, kubectl get Nginx. My bad. kubectl get pods. Perfect. So Nginx v1 is getting installed. But Abhishek, in this command, you provided something here. Like, why can't I just do Helm install Bitnami Nginx? You need to provide name of the release, right? Just like repo and chart, there is another thing that you need to learn, which is called as release. So release is nothing but a deployed instance of your chart. Definition can be confusing, but it's a very simple thing. You know, why do you provide a name of the release here? Maybe two different teams in your organization, or today you want to install a specific version of Nginx. Tomorrow you just want to upgrade. So you need a clear distinction. So you can just call it as Nginx v1. Tomorrow when you upgrade, you can just change it to Nginx v2, or you can install two different versions of your chart, right? So you call them as releases in the world of Helm. So whenever you are installing any specific chart, just provide name of the release for that particular chart. Abhishek, I installed Nginx. In the same way, can I also install Prometheus? Why not? Just search for it first. Helm, search, repo, bitnami, pipe grep, Prometheus. Yeah, Prometheus. I hope the spelling is right. Yeah. So it says there is a chart called bitnami/Prometheus. Let's see if that works. kubectl, my bad. Helm, install, let me call it as Prometheus itself. Bitnami/Prometheus. Now let's see if it is going to install Prometheus for us. kubectl get pods. Great. It is installing Prometheus Alert Manager and also Prometheus Server. Now, you might have realized how powerful is Helm. Just using one command, repo add is something that we did only once. We just added Bitnami repository one single time. But after that, I am just searching if that package or if that chart is available in the Helm repository. If it is available, I'm just running the Helm install command, right? So till now, what did we learn? We learned three commands. One, we learned about Helm repo add to add the repositories. We learned Helm search command to search for a particular chart in the repository. Then we learned Helm install command to install that particular chart. Great. Abhishek, what if I want to install something that is not part of Bitnami? Maybe let's take an example. I'm just giving it a guess. Let's say something like Argo CD. I'm not sure if it is available as part of Bitnami. Let's just give it a search. Helm search repo followed by Bitnami. Yeah, pipe grep hyphen I Argo CD. Just to search in a case insensitive way. Yeah, so you can see that Argo CD is not part of Bitnami. And similarly, let's say I'm working on AWS and I'm interested in installing AWS load balancer, ingress controller. See, even that is not available. AWS ingress controller is also not part of Bitnami. In such cases, you don't have to panic because it is not your responsibility to create Helm chart for it. Of course, if you want, you can do it. But by default, what you can do is you can just search for AWS documentation. I just search for install AWS load balancer controller with Helm. And if I scroll down, there is this section which says that Abhishek, this is the repository where EKS or ALB controller is available. So it says you can just run this command Helm repo add. This is the name of the chart. They called it as EKS. And these are the EKS charts. And it's always a best practice. Whenever you are installing, just update the chart. As I told you, update the repository, my bad. Okay. Now if you search for Helm search repo EKS. So you will see there are charts related to EKS and one of the chart is ALB controller. Grep ALB. It might be called as elastic load balancer maybe. Okay, there must be something with that name. So they have app mesh controller, they have, it should be somewhere AWS, or let me just search for load balancer and see grep load. Yeah, so AWS load balancer controller. Yeah, I mean, name might be different, but AWS load balancer controller. Now you know what I need to do. Helm install name of the chart, name of the release, my bad, followed by EKS/ALB controller. So we can quickly do that. Helm install, I'll just call it as ALB as the name of the release, and EKS slash AWS load balancer controller. Okay, it says because of some restrictions or there might be some prerequisites for it. But however, now you learned this is how you look for a chart and this is how you install a chart within the repository. So there might be some steps where, you know, along with Helm install, it is asking to pass few arguments. Right now, you don't know what are these arguments, what is values.yaml. So that's why I'm not going into it. But by the end of this video, you will understand what are these arguments and why are they passing them. Cool. Okay. So we learned how to install using Helm, but I told you, you can also uninstall using Helm, right? How can you uninstall using Helm? It's very simple. Helm uninstall Nginx. Okay, it says what was the command that we used to install Nginx? Helm install, uh, or I can just do Helm list, right? So we said Nginx v1. So I just listed the releases. Now I can just do Helm uninstall Nginx v1. That's it. Nginx is uninstalled. If I search for kubectl get pods, either they are terminating or it is completely terminated. Similarly, let's uninstall Prometheus. Helm uninstall Prometheus. If you observe carefully, what I am providing here, I am providing the name of the release, right? Because as I told you, release is the deployed instance of your chart. Whenever you are installing the chart, you are providing a release name for it. So during the uninstallation also, you just need to use the name of the release. Cool. So we also learned how to uninstall using Helm. Now, one of the important things to learn, okay, you learned about third party applications, you learned about Kubernetes controllers, but if you are working as a DevOps engineer, right, within your organization, how can you bundle applications as Helm charts? And how can you deploy those applications as Helm charts on your Kubernetes repositories, clusters? Or maybe you can share that with some other people and how can they deploy your applications as Helm charts? This is important to learn as DevOps engineer. Let's try to understand that. And for understanding it, I'll take a classic example. Instead of just explaining with some random things, let's assume you are a DevOps engineer working for e-commerce application, or your company is an e-commerce company. And within this e-commerce company, you are a DevOps engineer for a team where you are working for payments and you are working for shipment, right? So payment and shipment are two microservices that you are working for. And also, like, let's say there are only two microservices that your organization has, anything that you want to understand. Now, as DevOps engineer, you know, you will deal with deployment of both payment and shipment, right? So let's first see how you can create a Helm chart for payments and how you can create Helm chart for shipment. So first a chart for it, then a chart for it. Then I will add both of these charts to a repository, right? So that anybody can first add this Helm repository, somebody outside your organization, and they can either install this chart or they can either install this chart. Just like how we did with Prometheus. Bitnami was our repository and Prometheus was our chart. Similarly, the name of the company can be the repository. If the e-commerce that you're working for, let's call this as, uh, maybe let's give it a random name, best e-commerce or best commerce. So this is the name of the company, for example. So best commerce can be the repo name, and payments will be one chart under it, shipment will be another chart under it. So for doing this, we'll go back to our terminal, right? I'm not talking any source code. Let's not complicate it by taking source code of the e-commerce application. What I'll simply do is I will use a Docker image called BusyBox. So BusyBox is a sample Docker image. So for both payments and shipment, I will use the same Docker image. I'll just pass a log message to BusyBox where on the payments Helm chart, if you run it, it will say I am a payment service. On the shipment, if you run the same BusyBox image, it will say I am a shipment service. Because this is purpose of your learning, right? You don't need a source code because when you are dealing with Helm, you directly deal with Docker images, right? Or you deal with Kubernetes pods. So I've taken a Docker image called BusyBox and we'll understand both of it. Cool. All the steps are provided in this GitHub repository. Now, if you are unable to follow the commands that I'm executing, just go to 04 create Helm chart. So you will find every command that I'm executing right now. Okay, as step one, first let's see. Okay, great. So I'll create two folders, mkdir-p. Instead of Helm repo, I'll just call it as best commerce, right? And within this, payments and shipping. Now I'll go to best commerce repo. Cool. And you don't have to create multiple files inside it. What Helm does, so Helm provides a command called Helm create, where it creates the complete template that you need. So if I do Helm create payments, now within the payments folder, you will see lot of Helm related files are created. Just like Ansible. When you're doing Ansible Galaxy init, right? It creates the complete folder structure for you. Similarly, Helm create payments, right? It will also create a folder structure for us. And I will also do the same for another microservice, Helm create shipping. Now, ls-ltr, you have payments. And if I do cd payments and look for the files within it, there is chart.yaml, there is values.yaml, and there is a folder called templates. You can ignore this folder called charts. This is basically for dependencies. Let's say along with your application, you want to install Redis, or along with your application, you want to install Valkey. Then you need this child charts repository. For now, let's ignore it. There are only three important things. One is charts.yaml, one is values.yaml, and one is templates. So every time you run Helm create, these three things are created. CD, shipping. Again, you will see chart.yaml, values.yaml, templates. What exactly are these? Right? What is this chart.yaml? What is values and template? First, chart.yaml. So whenever you are creating your own Helm chart, chart.yaml acts as metadata for your chart. So you can provide things like who is the owner of the chart? What is the version of the chart? What is the version of application deployed in the chart? All such metadata related information you can provide as part of the chart.yaml. Then you have a templates folder. Now, what do you put within the templates folder? You will just provide deployment.yaml file. Okay. So to install Nginx or to install BusyBox or anything, you either need a deployment.yaml or you need a stateful set kind resource or you need a daemon set kind resource. Whatever is required, you just put that YAML file within the templates folder, right? And let's say there is a service account. Put the service account.yaml file. Let's say there is a config map. Put the config.yaml file. So take all the YAML files and put those YAML files within the templates, because you are creating a Helm chart for your application. So whatever are the resources that you need to deploy, or whatever are the resources that you need to bundle, you will put all of them within the templates folder. But Abhishek, where can I get all of these things? You must already have it, right? Because if you have containerized your application, and if you're already deploying your application within Kubernetes, you will have the deployment YAML for your application. You will already have the service account for your application. You will already have config map and all the required dependencies. So put all of them in the templates folder. Now, why do you need a values.yaml, right? Abhishek, what is the purpose of it? Very simple. Values.yaml is used to make any customization to the template. What does that mean? Imagine you have a UAT environment and you have a production environment. On the UAT environment, you want to install two replicas of your deployment, whereas on the production, you want to uh, deploy three replicas of your application. So what you can do, the deployment.yaml, which you put within the templates folder, you can customize it using the values.yaml. I'm going to show this practically, but values.yaml is used for customizing any file that you put within the templates folder. You can customize your deployment, you can customize your service account, config map, so that for different environments within your organization, you can deploy with different specs. Onto UAT, you can deploy with a specific replica count, you can deploy with a specific version of the image. Onto production, you can change those specifications. Not the version of image, but it's usually a bad practice. But replicas, or maybe resource request, resource limit, these kind of things. Great. So let's see this with, as I told you, with a busy box image. Now we'll go back to payments first. We'll start with payments. So within payments, first I will head to the template folder, and within the template folder, see, it already gave you bunch of examples, right? So I'll just update my deployment.yaml, vim deployment.yaml. I don't need all of this. This is just an example that is provided with lot of customizations. So I'll just remove this deployment.yaml file, and I'll replace the one that I already have. Okay. So this is the one that is in the GitHub repository. It looks same like your deployment.yaml file, but if you observe carefully, there are few variables here. The name of the deployment, there is a variable. The label of the deployment, there is a variable. For replicas, I just hard coded with one, but again, the match label, there is a variable. And even for the image of the container, there is a variable, right? Why are we providing these variables? So that we can customize them with the values.yaml. So how do I add the values.yaml file? So in the values.yaml file, just go back, vim values.yaml. Again, this is something that comes out of the box. You don't need the out of the box one. You can just remove it, or you can just update the out of the box one as well. Okay, let me just get rid of all of it. Perfect. And in the GitHub repository, I have provided you an example of values.yaml, where image, if you noticed in the deployment.yaml file, repository name was a variable. That variable will be updated with busybox. Similarly, tag was a variable which will be updated with latest. Pull policy was also a variable which will be updated with if not present. And I'm passing a simple app message. As I told you, instead of creating from the source code a payment service, shipping service. I'm just passing message to the busy box so that when we deploy payment service, it says it's a payment service. When we deploy a shipping service, it says a shipping service. Just a log message. That's it. So repository variable is updated with a value, tag is updated with a value, pull policy is also updated with a value. So if you look at templates now, templates and deployment.yaml, see this will be updated, name, name, image value, and the app message. Perfect. Good. We also have to provide a charts.yaml, right? As I told you, metadata is important. So let me provide the charts.yaml. I think it should be already updated. The default one should be good. Yeah, it is good. So it says payments is the name of the chat, and this is the version of the chat. This is the app version of the chat. I'm not going to change it because it looks perfect. Only thing I might want to change is app version. This is specific to your application. I'll just say 1.0.0. Great. Similarly, we'll also update the shipping service related thing. So let's go back to shipping. This is exactly what you would do when you join an organization, right? So within the shipping, again, you will go to templates and probably deployment.yaml, remove everything that's in the deployment.yaml. Out of the box, it provides all the variables, so it's not required. And this time, the only difference that I'm going to take between shipping and payments deployment.yaml. So I'll copy almost the same thing. Okay. I'll copy the exact same thing. Only in the values, I'm going to change it. Right? Deployment is same. Only in the log message, I'll just call it as a shipping service. In real time, you will change the repository name and the image name. For different microservices in your organization, you will have a different repo name and image name, right? In real time, you will just change that. Now, going back, values.yaml. So again, I'll just replace everything in the values.yaml and update this with again image, tag, pull policy, and a app message. Okay, great. So this is the values.yaml. I'll just keep it as is. Shipping service, save. Charts.yaml is already updated. Now, how do you create a Helm repository for it? But before that, you need to create a package, right? You need to bundle them into a chat. Command is very simple. Helm package shipping. Uh, Sorry, I just need to go back. Helm package shipping. Now this entire thing is saved as a chat. So you can see here a zip file is created. As I told you, it's a bundle, but in the world of Helm, we just call it as a chat. Then I'll again do Helm package payments. Another zip file is created. In the world of Helm, we'll just call it as a chat. Now, all that I need to do is I just need to run this command called Helm repo index followed by dot. Okay. Now, LSF and LTR, you will see this is the chat, this is the chat, and this is the index.yaml that got created using the Helm index command. Cat index.yaml. So it says this repository has two chats. One is the payment chat, one is the shipping chat. So you can just publish that index.yaml and you can just publish that entire bundle to either Nexus, Artifactory, or any centralized location within an organization, people who wants to use that Helm repository, they can just do it by using Helm add, sorry, repo add command, right? So right now I don't have Artifactory or Nexus, so I haven't created that. But otherwise, you just have to provide a centralized location. You can also use GitHub pages, and others can use the Helm repo add command to add it and look for charts within the repository. Now, that's not a very difficult thing to set up that Artifactory or Nexus. It's going to take a lot of time. So I'm just skipping it. Now, what you learned till now is more than enough. Now, during the installation, while installing EKS, you must have seen that they were passing some values. Now, what are these things? Now, these are nothing but values.yaml variables, right? Within Helm chart. So within the Helm chart for AWS load balancer, they have a values.yaml, and within that values.yaml, you are not using the hard coded values, but you are updating the values, right? That is what you can do using hyphen set. Whenever you are installing a Helm chart, so you can just look for if they have any values. If they have the values, you can set the values using hyphen set. But Abhishek, how can I look for the values? Like, how will I know within AWS load balancer, right? These are the values that I can set. Very simple. So, you can just copy the name of the chart. You can just say Helm show values followed by the chart. And it will exactly show you what are different values that you can pass. Whenever you are installing it in production or whenever you are installing it in multiple environments, you can use this particular feature. As you play with Helm, you will understand more about, why are you setting these values. But first, get started with the examples that I have provided in the GitHub repository. It is the best place to get started. So just go through the repository. I provided the link in the description, and try to practice what the things that we have learned in today's video. Two major things, right? How do you install the charts from the external repositories, and how you can create charts for your repositories? Because today is your first day, you might have felt templates values.yaml little confusing, but as you keep practicing, it's a very simple thing. Templates are used for customizing deployment, service account, config maps. Values.yaml is used to pass values to the templates. That's it. If you have any questions, do let me know in the comment section. Thank you so much for watching today's video. See you all. Bye bye.